Welcome to another video on Alkanol. Now, Alkanol can also be known as alcohol. Now, don't forget, when you are talking about Alkanol, alkanols are derivatives of alkanes. Now, what do I mean by that? When you observe, alkanols are single bonds because they are derivative of what? Of alkanes. And alkanes are also what? Single bonds. They are saturated. Now, you'll believe with me that alkanols, they have the general formula of ROH, in which don't forget that this R means alkyl, and this R is CnH2n plus 1. CnH2n plus 1, so we can have it to be OH. So that's why we can simply say alkanol general formula is CnH2n plus 1 OH. You should know that alkanols, I can say that alkanols, don't forget that alkanes have the general formula of CnH2n plus 2. So I can simply say that the reason why alkanols are derivative of alkane, one of the hydrogen of alkanes is being replaced with OH. So in short, alkanols have the general formula of ROH, in which the R is CnH2n plus 1. So we have OH. Now, and don't forget the member of alkyl. We have the first member of alkyl to be methyl. We have ethyl, propyl, butyl, pentyl, etc. These are the members of alkyl. Now, you can know all those properties, all those physical properties, but here I just want to talk about the classification. Now, what is the classification of alkanols? Alkanols can be divided into, we have the first one to be monohydric alcohol. Number 2, we have dihydric alcohol. Number 3, we have trihydric alcohol. And we have polyhydric alcohol. Now, what is the difference? Now, monohydric alcohol are those alcohol from the word mono. They only possess one hydroxyl group. Dihydric, that means 2, they possess 2 hydroxyl group. Trihydric means they possess 3 hydroxyl group. And poly means more than 3 hydroxyl group. That is the difference between the classification of alcohol. Now, under this monohydric is differentiated into, we have the primary alcohol. The denotation of primary is this. We have the secondary alcohol. Then we have the tertiary alcohol. And what's the difference? The difference between this is this. Now, that shows that if you are talking about the primary alcohol, secondary alcohol, tertiary alcohol, they are under monohydric. That is, they will only possess one hydroxyl group. That's the meaning. I'm going to be using some things to explain here. Now, let me explain the monohydric. Monohydric means, example, if you have something like this, if you have something like this, then you see this is CH3OH. This is methanol. So methanol contains only one hydroxyl group. Even you can have this. This is ethanol. Ethanol, that's that's 2 carbon. That's ethanol. That's C2H5OH. It's still monohydrate. So if you see any alcohol that contains only one hydroxyl group, then it is called monohydrate alcohol. Now, what is that hydric? The hydric, if you have something like this, if you have something like this, now don't forget that the number of carbon here is 2, and 2 means what? 8. So that's why we have it to be ethane, and we have 2 hydroxyl group. So the 2 hydroxyl group, it is positioned at the carbon 1 and carbon 2. So that's why we have it to be ethane 1,2 diol. Ethane 1,2 diol. Now you can have another one. Let's say you have this. Let's say you have this. Let's have it. This one is 3 carbon. And 3 carbon is what? Prop. So we have it to be propan 1,2 diol. So it's still example of what? Of dihydric. Now, let's go to trihydric. Trihydric alcohol. Now, if you have something like this, now can you see? This one is propan 1,2,3 triol. Propan 1,2,3 triol, because we have 3 carbon, and 3 carbon is prop. So that's propan 1,2,3. So the hydroxyl group is found at what? On 3 carbons. It is found on 3 carbons. And we include the position of those hydroxyl group. That's why it is propan 1,2,3 triol. Don't forget, there are rules to naming. You separate alphabet from number with the use of hyphen, but you separate number from number with the use of comma. You have to watch the organic nomenclature video on the channel so that you can understand the way to name the structures. Now, let us now go into the monohydric. I told you initially that monohydric is differentiated into the primary, secondary, and tertiary. So from here, the boiling point, don't forget, the boiling point of primary is greater than the one of the secondary, in which the secondary is greater than the one of what? Of tertiary. But if you are talking about all monohydric alcohol, monohydric, as the number of carbon increases, the boiling point also increases. So that shows that ethanol boiling point is greater than methanol. That shows that propanol boiling point is greater than ethanol. That shows that butanol boiling point is greater than propanol. And that shows that pentanol boiling point is greater than butanol. That is it. And at the same time, primary alcohol boiling point is greater than secondary alcohol, and secondary alcohol boiling point is greater than tertiary alcohol. What is primary, secondary, and tertiary alcohol? This is it. Come with me. If you have something like this, if you have a structure like this, This is methanol structure. This is methanol. This methanol is primary alcohol. Is primary alcohol. Now let me explain what is primary alcohol. If the carbon that holds the hydroxyl group, if that carbon only contain one alkyl group, then it is called primary alcohol. But if that compound contains two alkyl group like this, then it is called secondary alcohol. And if that compound contain three alkyl group, then it is called tertiary alcohol. So this is the difference between primary, secondary, and tertiary. Now, this is the carbon that holds the what? The hydroxyl group. It contains CH3, and CH3 is methyl. Now, let me quickly use alkyl group. Let me explain what alkyl group is. Now, what is alkyl group? Alkyl groups they have the general formula of CnH2n plus 1. Don't forget. And under the homologous series, number 1 is called met, number 2 is et, number 3 is prop, number 4 boats, number 5 pent, number 6 x, 7 ept, 8 oct, 9 non, 10 dec. Now, you will now be putting the family name is YL. So if I want to form methyl now, methyl, what's the number of met? 1. So I'll put 1 inside this general formula. That'll be C1, H2 times 1, that's 2 plus 1, that's 3. So that's CH3. So CH3 is methyl. Next one here, ethyl. So what's the number of et? 2. Let me put it inside the general formula. That'll give me C2, H, 2 times 2, that's 4 plus 1, that's what? 5. So that's C2H5. Next one is propyl. Just be adding YL to this. Propyl, prop is 3. So it starts inside the general formula, that's C3. H2 times 3, that's 6 plus 1, that's 7. Next one, we have butyl. That's C4. H, 4 times 2, that's 8 plus 1, that's 9. Now, you can continue the rest. This is the main knowledge behind alkyl family. Now, having known alkyl family, let's come back to this. That shows that this is CH3 and this is methyl. And that's how we have it to be methanol with the addition of what? Of OH. But this only contains one alkyl group. Now, imagine you have something like this. You have CH3, C, hydrogen, you have CH3 here, you have OH. Now if you check this one very well, this one contains two alkyl group. We have CH3 here, we have CH3 here. Don't forget, if I want to name this, I will name it as the longest bond is there. According to the naming of organic compound, this is the longest bond, and it is 1, 2, 3. That's prop. So we have it to be propane. But the position of the alkyl group is at the second carbon. Either you start counting from here or start counting from here. So we have it to be propan 2-ol. So propan 2-ol, if you get the structure here, it's contain one alkyl group, R is here, another R is here. So that is what? This is secondary alcohol. Now, imagine you have C2H5, you have C, you have CH3, you have OH, you have C2 or CH3 here. Now check this. This is tertiary because this is ethyl. Ethyl is one alkyl. This is methyl. is another alkyl. This is methyl, another alkyl. So if it contains 3 alkyl group like this, that is called what? Tertiary. And how will you name this? The longest bond will either be from here or to this place. It is either here, this is the longest bond. Consider this is 2. So 2 carbon plus this, that's 3. Plus another one here, that's 4. Or you take it as 2, 3, and this 4. So I want to take it like this. So this is the longest bond. If I take this as longest bond, then this will be the ligand. And you have it to be carbon 1, 2 here. If you start counting from here, it will be 2, 3. So it will have a large value if you start counting from here. But if you start counting from here, it will be 1, 2. So that means this should be at number 2. So we now have, this will now serve as a ligand or substituent. That will now be 2 methyl, because this is a methyl. And what's the parent name? 1, 2, 3, 4. Don't forget there is 2 carbon here. So 1, 2, 3, 4. And that's both. 2 methyl, butan. And what's the position of the functional group? Is at what? Number 2. That's 2 or. Now that shows if I have something like this, CH2OH. Now get this structure well. If you want to write it in full, CH3, you have CH2 like this, and you have OH. Now this one would be primary, because check, this is a carbon that hold this, and this carbon only contain one alkyl group like this. So it contains one alkyl group. Others are what? Are hydrogen. So, but the name, don't forget this is 2 carbon, and 2 carbon is what? Earth. So this is ethanol. So that shows that ethanol is also what? Primary alcohol. So let's see more example. The question says 3-methyl-pent-3-ol and 3-methyl-pent-2-ol are types of dash and dash alcohol respectively. And we are given this option. Now, how do we resolve this? Now, solution. We have to restructure the given question. The first one, 3-methyl-pent-3-ol. Now, if you want to start, you have to start with the parent name. And parent name is pent. And we are talking about pent. Pent is 5 carbons. So, firstly draw 5 carbons. You have 5 carbon. They now said the functional group is at number 3. So you are the one to decide if you are to start the counting from here or to start from here. So if I'm starting from here, the functional group is here, number 3, OH, 3-ol. So it's at number 3. Then what's the ligand? The ligand is methyl. And don't forget methyl is CH3. And they also said 3-methyl. So that means the methyl is also at the carbon 3. So can you see? Now, if I should complete this, don't forget, each carbon must be tetrahedral, that is, must have 4 bonds. So I will have to complete the remaining aspects with hydrogen, 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 hydrogen. If you check very well, according to the structure I gave you, that is, the carbon, your target is to get the carbon that holds the functional group. So your target is the carbon that holds the functional group. Now if you check this very well, this is the functional group. And this is the carbon that holds the functional group. This carbon that holds the functional group is attached with a ligand, with an alkyl group here. Another alkyl group is here. Then another alkyl group is also here. So that means how many alkyl group is here? Because this one is CH3. But if you count this one is C2. H, how many H is here? That's H5. And if you see it, that's ethyl. This one is also C2. And how many H? That's H5. That's also ethyl. But all I want to know is how many alkyl group? 1, 2, 3. That's 3. And if it is 3 like that, that means it is what? It is tertiary. So that's tertiary alcohol. And the second one is 3-methyl-pent-2-ol. 3-methyl-pent-2-ol, you start with the same process. You are going to start with the parent name, and the parent name is here is pent. That's 5, 2, 3, 4, 5. And if you check this time around, the functional group is at number 2. So it is either we start counting from here. If you start counting from here, you can place your functional group here, OH. You can even place it at the top, either of the two. If you start your counting from here, it will be the same thing. Okay? For those of you that may ask that, okay, if you start your counting from here, that's OH. Now, if it's OH like this, I'm giving you two conditions. If you start your counting from here, or if you start from here. If you start from here, this is 2 all. So it's at number 2 here. If you start from here, it is 2 here. You know, say don't forget, we are starting from here. This one is, we are starting from here. This is carbon 1. This is carbon 1 for this case. Now, this is 3-methyl. It is this number 1, 2, 3. So that means a methyl is here. That's CH3. Let's put it here for you. 1, 2, 3. So this is CH3 as well. Now, if you should complete this with hydrogen, know that this will be have hydrogen, hydrogen, hydrogen. Another hydrogen will be there. Don't forget, each carbon must have 4 bonds. We have hydrogen here, hydrogen, 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 hydrogen. If you understood this, then you don't need to complete the bond again. Thus, for those that don't understand, that's why we are doing this. Now, if you check this very well, this is the carbon that holds this functional group. This is the carbon. And this carbon is attached with an alkyl group here. And another side with an alkyl group. So it's the other side of this carbon is not an alkyl group. So the only alkyl group we have here is 2. They are just 2. This is normal hydrogen. So that means, and if it's attached with just 2 alkyl group and others is hydrogen, then it is called what? Secondary alcohol. It is called secondary. But if it is 3 alkyl group, it is called tertiary. But if it's just only 1 alkyl group, it is called primary. But this is just 2 alkyl group. This one is hydrogen, not alkyl. Because this one here is CH3. But if you count this one out, this one is, how many carbons is there? This is 4 carbons. And hydrogen, this is 3, 4, 5, 6, 7, 8, 9. That's C4H9, and that is butyl. And that means we have 2 alkyl group here, and that means this is secondary alcohol. Now, that means the answer is, the first one is tertiary, and the second one is what? Is secondary. So that is the answer to this question. Now, let us proceed to the naming of alcohol. How will you name alcohol? Before we proceed to the naming of alcohol, I want us to quickly name this so that I will know if you truly got the organic nomenclature video I sent before this. Now, how will you name this? This is called condensed structure. Before you can name this, you have to restructure this. Let us restructure. This is CH3. I hope you are following me. We have CH3 here. And bond with CH2. So we have CH2. Are you following? Then bond with CH. Just CH. Then we have the double bond. Then we have 1 carbon. But on this carbon, we have another CH. And we have the triple bond. Then we have a carbon. Then we have CH3. Now you have to verify if those carbons are complete. Now let us verify. We have this to be 4. This one is also 4. This one is 1, 2, 3, 4. It's also complete. 1, 2, 3. So that means there should be CH3. We should have, sorry, if you check this very well, there's a mistake here. Let's restructure this. We have the CH3. Let us do it. We have the CH2. We have the CH. We have the double bond. Now it is CH. Sorry, I made a mistake by putting the C first. No, then I made I now said CH. No, it's not CH. This C stand alone, this is the CH. So it is CH first, then C, then the triple bond. Then we have the carbon, then we have the CH3. So this is it. Again, this is the CH3, CH2, the CH, the double bond, then the CH, then the carbon here, then the triple bond, then the carbon, then CH3. We check, don't forget each carbon must be tetrahedral, like 4 bonds. Now, if it is 4 bond, you have it to be, this one is 4, there's also 4, 1, 2, 3, 4, there's also 1, 2, 3, 4, this one is also 1, 2, 3, 4, this one is also 1, 2, 3, 4, this one is also 1, 2, 3, 4. So each carbon must be tetrahedral, like 4 bonds. It must not have more than 4 bonds. Now, once you have it like this, now you now need to, you have to name this straight up. And how will you name? We have the parent name. This does not have ligands, so this will be the parent name. Let's see. The parent name, you have to go and watch the organic nomenclature video I sent. The parent name is the longest carbon to carbon chain. And if you have this one is 1, 2, 3, 4, 5, 6, 7. 7 is EPT. So you have this to be EPT. Now you have to place the ligands here to be in the lowest possible number. To know the place of counting, the law says, after you've discovered the parent name, the second law says, now this parent's name, we now need to put them in the lowest possible number. Now, if we should start our counting from here, the two functional group will be 1, 2, 3, 4. We have 4 here. We have 1 at number 4, 5, 6. We have 1 at number 6. If we should start our counting from here, the total number of the position of the functional group will be 10. But if we should start our counting from here, it will be 1, 2. We have 1 at number 2, 3, 4. 1, 2. 1 is at number 2, 3, 4. 1 is at number 4. So it becomes 6. So the lowest one is 6. So that's why we have to start our counting from here. You cannot start from here because it will give you high value. And that's why we have it to be heptane, or you have it to be hepts. Hepts. The parent name is hepts. Hepts. And what's the position? So don't forget we are using this. The position of the double bond is 1, 2, 3, 4. We have it to be hepts 4A, because that double bond is alkane family. Alkane family, hepts 4A. Then what's the position of this one? That's 2. 4A, then 2I. Hept 4A, 2I. So that's the name of this structure. Now let us go straight to the naming of the Alkanol. Straight up. Now we have laws. I'll give you 3 laws. Alkanol's naming. And the first one. So Alkanol's naming. The first law. Law 1. Now the first law says that alcohol can be named as derivative of alkyl group attached with hydroxyl group. I've explained to you what we mean by alkyl group attached with hydroxyl group. Therefore, the word alcohol should be added. The word alcohol should be added with the alkyl group. Example. If you have something like CH3OH. Now I told you that CH3 is what? Is methyl. So we can name this as methyl alcohol. You can have C2H5OH. Then this one can be named as ethyl alcohol. On a real sense, we can name this first one to be methanol. Don't forget, this one is IPAC name. I'm still coming to that. On a real sense, we can call this what? Ethanol. But there is a rule that says we can name the alcohol in this format with an alkyl group. So if you have something like CH3, CH2, CH2OH, this one is 3 carbon. That's prop. So we can have it to be propyl alcohol on a resistance which is what? Which is propanol rather. Now lot 2. Let us go to lot 2. Now you can name alcohol as well, even some other organic compounds in terms of alpha, beta, and gamma. Now the alpha carbon is the carbon that is next to the carbon of the functional group. Now check the carbon that holds the functional group. The carbon that is next to that carbon of the functional group is the alpha, and beta is the carbon next to the alpha carbon, and gamma carbon is the carbon next to the what? To the beta carbon. So that is it. Now let us cite some examples. Now if you are given something like this, CH3, CH2, 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 OH. And you have something like this, you have the Cl here. Now we can name this, on the norms. This is the longest bond. And I can name this to be 1, 2, 3, 4, 5. And 5 is what? Pents. But the position of the ligand here is at number 3, 1, 2, 3. So this is 3 chloro pents 1 or pents 1 or, because the alcohol here is found at what? Carbon 1. But I can name it in terms of alpha, gamma, and beta. This is the carbon that holds the functional group. So this carbon here, now for this one now, in this case, this would be alpha, this would be, let me name it here, this would be alpha, this would be beta, and this would be gamma. So if I want to name this, I can say the gamma is found here, and the chlorine is found at the gamma, so that would be gamma chloro pent 1 or. Now the reason why this alcohol is not following this order is because alcohol does not have its own function, it does not have its own carbon. Now alcohol is ROH, but if you talk about other organic too, they have their own functional group, like RCOOH, RCHO, ROR, sorry, we have RCOOR. Now most of these, they have their own carbon. So it's only this one that does not have its own carbon. So because of that, we take the carbon attached to the hydroxyl to be what? To be alpha, the one next to be beta, and the one next to be what? To be gamma. So that is the explanation. But in the case whereby we got to the alkanoic acid now, it will be different. Now, what am I saying? If you have for the alkanoic acid, you have something like this. You have O, then you have OH here. Now, in this case, this will now be the alpha, this will be the beta, and this will be the what? The gamma. Because this is the carbon that holds this functional group. This carbon here, is part of the functional group of alkanoic acid. I don't know if you are getting it. This carbon here is part of the functional group of alkanoic acid. But carbon is not part of the functional group of what? Of hydroxyl group. So in short, if it's for hydroxyl group, so we can say in short, the alpha carbon is the carbon that contains the hydroxyl group. That's for this one, for the alcohol or alkanol. Then we can have the beta to be carbon next to alpha, and gamma is the carbon next to what? To beta. But this one now, this rule I gave you first here is for those that have their own carbon. They have their own carbon as part of the functional group, like alkanoic acid, RCOOH, even alkanoids, RCOO-R. We can have RCO-R. We can have RCHO, etc. So, but this one now, let's continue. Lot 3. Lot 3 says the alcohol can be named using IPAC system. Like, now, if you want to use IPAC system, that is their IPAC naming, then just go straight. Once you understood the naming organic nomenclature of the first season I gave to you, then you are good to go with this. Now let us just look at some examples. Now example is this, the IPAC system. If you have CH3 CH2OH. Now if you can see, this one is just 2 carbon, so this one is what? Is ethanol. If you have CH3 CH CH3, you have OH here. Now if you see this one now, this one is 1 2 3, so that's prop. We can call it propan, and the position of the functional group here is what? Number 2. So we have it to be propan 2-ol. Okay, what if you have something like this? CH3 2 CH CH OH CH3. Now if you are asked to name this, you have to open this up. Now see, this one means the CH3 you have here is 2, and is attached to this CH. CH3 you have here is 2 and is attached to this CH. How will you see this? Now is CH3, so it's attached with CH. So this is the CH, but CH3 here is attached to this CH. So this is it. 2 of CH3 attached to this CH. That's the meaning. Then we have CH as well. This CH. Then don't forget we have OH, but this OH attached to this CH. Then we have lastly CH3 here. Now, how do we name? We have to check the longest chain. Don't forget, this will be the longest chain. If you have this to be longest chain, so we can have it to be, there's a methyl here, but this should be the carbon 1, because the functional group is here, so the functional group will be favored. So this will be the carbon 1. So we can just have it to be 1 2 3. So methyl is at number 3. So we have 3 methyl. 1 2 3. So this methyl is at number 3. But the parent name is 1 2 3 4. So that's both 3 methyl, both or butan. But the position of the alcohol here is number 2. Butan 2-ol. 3 methyl, butan 2-ol. That is the name. Now let us see some examples. More examples. What if you are given something like this? CH3 CH CH3 CH CH2CH3 CH3 CH2 CH2OH. Now if we want to name this, we have to check the longest chain will still be here. That will be 1 2 3 4 5. That's 5 carbon. If you take it to be 1 2 3 4 5, it's still the same thing, but because of the complexity, so that's why we have to take it straight like this. Now if you take it straight like this, that means this is a ligand and this one is a methyl. This is also a ligand, that's C2H5, and C2H5 is what? Is ethyl. You can see the carbon is 2 and the hydrogen is 5, so that's ethyl. Now we have to follow alphabetical order. So now, but this will be the carbon 1 because there is a functional group here, so this will be the carbon 1. Now since this is the carbon 1, because the functional group is here, but you have to name ethyl. Et will come before met alphabetically, so E will come before M. So we now have it to be 1 2 3. So ethyl is the number 3, so we have it to be 3 ethyl. Then methyl is at number 4. 1 2 3 4. Methyl is at number 4. That's why we have 4 methyl. Then what's the parent name? The parent name is 1 2 3 4 5, and 5 is pent. We have it to be pent 1-ol. You can have it to be pent 1-ol, or we have it to be pentanol straight up. You can have it to be pent 1-ol, or we have it to be pentanol straight up. Now in the comment section, let me have the name to this structure. Let me have the name to this structure at the comment section. Let me add the name to this structure. Now, what is the name of this structure? Thank you very much for today's class. God bless you. Have a wonderful day. Thank you. Like, comment, and subscribe. Share for other people to use.